Alright, we are on our way right now to do this whole math video thing for Algebra 2. It's going to be intense. We're going to teach you guys about geometric and arithmetic series, I should say, and sequences. It's going to be pretty sweet. I have my dog Tatiana. We're actually missing our black friend Lyle. Sorry, our African American friend Lyle. He didn't want to come. I'm just kidding. He had to take the bus home, so we're going to be without his services for right now. Hopefully we can get some footage in with him soon. But for now, let's go learn some geometric and arithmetic series. Today we are going to go over arithmetic and geometric series and sequences.
This is the arithmetic sequence, and to find the explicit formula you need the first term, the difference, and the number of terms there are. And to find the difference, you first subtract the first term from the second term. So you do 9 minus 5, and it's 4. So you put 4 in for D right here. And then the first term is 5. And the number of terms is 4. Oh wait, no, I messed up. The n is of how many terms you want to find. So if I wanted to find the 10th term, I'd put 10 here. 10 minus 1 is 9. It's 9 times 4. 36. 9 times 4 is 36, and 36 plus 5 is 41, and that 41, you put A, 10 equals, and you get 41. That's how you find the explicit formula and the common difference.
Now we have a geometric series. This problem down here represents a finite geometric series. So we're going to want to find the sum of this. In order to find the sum, we have to take what we know. We know our first term is 6. We take the division of our first two terms, which would be 12 over 6. And this is our common ratio. And we know that our nth term is 1,536. Now, taking what we know from this, we have to plug some of this information into the explicit formula to try and solve for n. Now the explicit formula looks like this. A sub n equals A1, so our first term, times R, which is our common ratio, raised to the n minus 1 power. So we can plug in everything that we know. So, n equals 9. Now that we have solved for n and discovered that n is 9, we have to try and find the sum of this finite geometric series. Here we have the formula for finding the sum. And once again, we're going to take the information that we already have and plug it in and find our sum. So we have S sub 9 equals first term of 6, parentheses, 1 minus 2 raised to the nth, which is the 9th power, all over 1 minus R, which is again, 1 minus 2. So the first thing we're going to want to do here is figure out what 2 to the 9th power is. Being that we already solved and figured out 2 to the 8th power is equal to 256, that can mean that this is equal to 512. Once again, that's all over 1 minus 2. It would appear that I'm running out of room on the board. Hold your horses. Now we do our parentheses. We know that we have 6 parentheses 1 minus 512 all over, and we'll just call that negative 1. Alright, 1 minus 512 is equal to negative 511 all over negative 1. So 6 times negative 511 would be equal to, oh, sorry about that guys, a little sloppy. Negative 6 times 5, 30, and then 6 times 11 equals 66. All over negative 1. Nothing much really changes here. This is just going to make it a positive number up top. So our final sum would be positive 3,000. No 166. Boom. That is how you find the sum of a geometric series. We are currently at a second day of filming.
Yes.
We finally found our African American friend.
Yes.
He's about to show us some geometric sequences, is that right?
Yes,
sequences.
while using explicit formulas.
That's
Maybe
what's up.
some recursive.
That's what's up, guys.
Probably not.
It's gonna be good. Featuring Tristan Tucker for a second. Wow, where are we going right now?
Oh, we're about to go, we're heading into Miss Cassie's class right now, then we're about to go to B-Camp's class right now. So, we're going to 2 different classes right now.
Now we're moving on to the next part, which is geometric sequences. This is the explicit formula. You can use this explicit formula to find any term in a geometric sequence. We use this geometric sequence of 4, 12, and 36. Now you apply these numbers into the explicit formula to find whatever term you want. We're gonna find the 10th term in this sequence. So you replace n with 10. Oh, there. You replace n with 10, and you use the first term in the first part of the formula. Now for the r's ratio, we're multiplying by a ratio of 3. So you multiply 3 to the power of n minus 1. So since it's 10, we're doing 10 minus 1. Now, this is the formula. So 4 times 3 to the 9th power. So it's 10 minus 1. 9th power. And 3 to the 9th power is 3 to the 9th power is then you're going to multiply it by 4. And when you multiply that, yeah.
Can you speak a little louder, please?
You get 78,732. And that's the 10th term. So this geometric sequence, but
Excuse me, a
you
little
can use-
louder.
You can use the explicit formula to find any term or any term in the geometric sequence.